This Hangout on Air is live. Hello, everyone, to the January Patreon exclusive Hangout. Again, if you didn't catch what I'm doing with this one is we're splitting it up into the Hangout on Air is live. Hello, everyone, to the one second. There are a few windows playing this stuff. That one. Okay. Let's start again. So we're doing something new with this month's Patreon Hangout because the last ones were sort of empty, and I don't know. When there's nobody there, there's really no point of doing them, and I guess it's not hurting anyone. So what we're doing is the $5 per month patrons are here live. 14 people already. Hello there. And everyone else who's on Patreon can ask questions on the announcement post, and we'll get access to the recording of the videos. So for those of you who are live here, yes, Pauso here, I'm seeing you, part-time Ronan also here. You can chat through the YouTube live chat, and if you have live questions, ask them through that. And until we have a few lined up there, I'll go through the questions on the posts on Patreon. So let's start out with that one. So there we go. So there's the announcement for opening up Q&A Hangouts. And I had a quick look through these, and these look pretty much, they all look worth answering because it's good questions. So what's my favorite design software? Let's start right with that one. I should put Super Chat on screen too. I don't have Super Chat yet. That is still exclusive to the bigger creators. What is my favorite design software? So right now I am using Onshape a whole lot. I'm using well, that sort of parametric CAD. That's my background. I used to use a whole lot of SolidWorks, but as you know, I am not a student anymore. I don't have access to SolidWorks anymore. So that's sort of a trade-off. By the way, are you guys seeing this thing backwards? One second. That's sort of a trade-off once you finish your your college years. Essentially, you don't get access to those free software packets anymore. I will try out Fusion 360, but in general, that is that area of parametric sketch-based CAD is what I'm using for pretty much everything. So yeah, I hope that answers that. Then there's two questions on essentially stepper driver microsteps and how they are missed or not. So there is a bit of misconception happening there when it comes to stepper drivers, microsteppers, or microstep implementations on the different drivers, because you often see these charts of, well, one microstep or one 1/16th microstep is going to have only 1/16th of the torque of a full step. That's not exactly true, because what you're essentially seeing is how a stepper motor will work is it has those 200 steps per rotation, and when it is at that one full offset from one step to the next, and the stepper driver wants to pull it that one full step forward, then it's going to have its maximum torque. However, if you only try to move that 1/16th step forward, it's only going to have that 1/16th amount of torque, because the phase offset essentially from the magnet inside the motor and from what the coils want to do is only going to be 1/16th as much. So yeah, that's that. And of course, every stepper driver does have a different implementation. There are some fixes for the DRV8825 that just use diodes on the outputs that sort of offsets the, I guess, the voltage sensing inside the driver chips. So yeah, I guess that's going to be a topic for an entire video. And yeah, he's specifically asking for the follow-up on the smoothie board in the Atom 2.0, I guess, yeah, on a Delta a few months back. The thing is, with that upgrade, I ran into a few other issues when it comes to the Allegro drivers and the Texas Instruments drivers. So it seems like the Allegro drivers, the ones that we've been using all the time, the A4988 or 4983, they prefer the low inductance version of your stepper motor. So the high current, low voltage, low inductance ones. The TI drivers prefer the exact opposite. So the TI ones seem to work better with low current, high inductance ones as used on the Atom 3D. And the thing is, by default, the Atom comes with those TI drivers, and the smoothie board comes with the Lego drivers. So it wasn't just 32-bit versus 8-bit at that point, but it was also TI drivers versus Lego drivers. So yeah, that's going to have to be a bit of a deeper investigation, just looking into how well the stock board does with the Lego chips, and how well the smoothie board maybe does with the TI chips, because you can wire those in. So yeah, by the way, guys in chat, you are live, you can ask your questions there too. So until then, I'm just going to keep on moving through the questions under the Patreon post. So Jonathan's asking, what is your review timetable and how far ahead are you planning? So that's been something that I started doing a bit better in 2017. That's been one of my one of the things I wanted to do. So typically a review can be between 2 weeks and 2 months. So depending on how well the hardware does, depending on how many issues I run into, and for example, the Ultimaker 3 that I have, my machine sort of had an issue with the active bed level, because there's going to be a review of the machine this week, or next week, I guess. And the way it works is it actually uses it has a capacitive sensor that senses the distance to the bed, and then it uses the hot, and it actually presses down onto the bed until it stops, until it hits the bed and pushes that down. So what they're measuring is not that distance offset once it reaches a certain distance, but it actually measures when that distance stops changing. So it's an analog sensor that can actually sense the distance and recognize when the hot end actually touches down on the bed. And that sort of wasn't working that well. So that's why the Ultimaker 3 review took a bit longer. Also the Markforged one, that one took a bit longer than expected as well. So it always depends. I always try to figure out stuff before I release a review. That's also one of the things with a TiVo machine, but we'll see about that one. But there's no I get the thing and then it's stage A takes 6 days, stage B takes 3 more days, and then it's relatively flexible. Yeah, so in chat, Goyland, I do have that new Replicate. I do have the manga screen with it, and yes, I am planning on reviewing that. It is going to be used on the Mendel 90 on that rebuild, which I guess I just have to take some time for that to get it to a go Elan. Go Elan. I just have to get it to the point where I can actually plop some hardware in, because at the Mendel 90, that is going to be the reference platform for any 3D printer component reviews from, well, I guess from the point when it's going to be finished. And let me finish the Ultimaker 3 review, and then the videos that I have to do immediately are a bit further out. So I guess that's going to be one of the next things that I can start working on. Yeah, Shai is asking, thanks Tom, looking forward to it regarding the stepper driver discussion. Repetier versus model and why? I think that was asked on the in the comments as well. The thing is, with 8-bit versus 32-bit, you're not just getting that extra processing speed, you are also getting more features that 8-bit just physically can't handle. I guess it is physically. It just doesn't have the processing power to do that. So, for example, on the Atom, we saw that 8-bit wasn't powerful enough to even drive the regular. I think it has the 4-line character-based LCD, and it wasn't able to drive it while doing the delta calculation. So while the printer was running, the entire thing was barely usable. So the display had like 2 or 3 seconds of lag at a time. And That's like the other big reason for 32-bit. Of course, also you're getting Wi-Fi. You're getting, in the case of the Replicate ecosystem with the BeagleBone Black, you're also getting a full-blown Linux system which does everything for you. But as far as the 8-bit firmwares go, Marlin versus Repetier versus, well, Sprinter. Yeah, I guess Sprinter is not really that well developed or well supported anymore. It sort of doesn't make that much of a difference. There are a few implementations, like the ones that Prusa is doing with the fixed point rewrite of Marlin that promises better performance, but in general, like 8-bit is at its limit. I feel like, where yes, it works for pretty much everything, but there's not much wiggle room left and right, or not much room to improve. Supposedly, Brook Drum has gotten the. Oh, are they using? What's their firmware called? They're doing sinusoidal acceleration and deceleration for the machines on an 8-bit processor. As far as I know, they have a co-processor. There's definitely a 32-bit processor in there. I don't know if that one's driving the stepper motors as well, but they're doing some new stuff with like acceleration and deceleration, which should really help with particularly with the Printable Symbol, which is a mechanically relatively soft or flimsy platform if compared to other machines, at least. So that's something that you can do with a lot of software effort, but again, 32-bit is just it's just so much nicer. Right. Well, let's head back to the screen cap. So he seems to be German or Austrian. Michael Lehenbauer is asking a few questions. So these are all pretty good questions. Any upcoming machines upgrades I'm excited about, or events I'll be attending? So that's actually that's a really interesting one. So as far as machines and upgrades go, so I believe we've got the basic 3D printer figured out. So stuff like stuff like a Prusa, stuff like an Ultimaker 2 Plus equivalent. That's pretty much figured out. The Ultimaker 2 Plus is a great machine. It just, it does its job. We don't need that much more or that much better hardware unless, we get into the entire linear carriage and, making the machine super stiff and maybe adding servo drives and getting it active feedback there. That might be an upgrade when, as far as speed goes. But like the machines themselves, they're pretty darn good at this point. I don't think we need to figure out that much more when it comes to the machines. Maybe if you go into like printing PEK and that sort of stuff, that might require some new hardware. But machines are super good. The big thing, the big challenge for 3D printing, I feel like, is CAD is making a powerful enough CAD package available to everyone, and not just making it powerful enough like Fusion 360. If you hand a third grader Fusion 360, they're gonna walk away. They can't deal with it. If you give Fusion 360 to a common non-maker person, they can't use that. So something that is powerful enough, intuitive enough, and maybe geared towards 3D printing that they can use to create models. I think that's going to be our next big challenge. And once you figure that out, that's like the next big step. Of course, dual extrusion with the Ultimaker 3, with the BCN machines, that is a big part in in making modeling less restricted, because you can just add support material that works and then just dissolve it in water and be done with it. But until that's the standard machine, we need better CAD. What about Tinkercad? Is that going in the right direction? It is. It's a good start. I feel Tinkercad is a bit too restricting, but something along those lines. But I'm not sure what the future for Tinkercad holds. It is part of Autodesk, as far as I know, and part of that 123D. Is it? Whatever. Yeah. But that's that thing. So machines upgrades, really, the better the machine works, that's great, but there's like nothing in particular other than like dual extrusion and multi-material that I'm really feeling, you know, needs to be implemented to move 3D printing forward. How do I stay up to date on 3D printing? Come on, start changer. On 3D printing happenings, new machine, cool designs, etc. Do I follow any blogs? So essentially, for me, that is all social media. That is all Google plus Twitter, Facebook not so much, but those two, Twitter for the most part. You know, you really run into the important bits. Yeah, I do work with all 3DP now and then, but for the most part, social media. Auto bed leveling, we did touch on that too, and the big question there is, how do you get a 3D printer as reliable as a 2D printer? So first off, 2D printers aren't reliable. If you own a 2D multifunction scanner printer, you know they fail all the time. The thing is, they give you some info about where they fail. It's like when they have a paper jam somewhere. My printer is actually right there. So when they have a paper jam, or when they, you know, clog a nozzle, you are going to see that, and you have diagnostics option built in. 3D printers don't really have that. However, a 3D printer can work really reliably if you have a tightly set of parameters. So, for example, what the Ultimaker 3 is doing with the NFC tagged filament, that eliminates one possibility of loading the wrong filament. It also gives Cura all the right print parameters for their exact filament. It just takes, you know, that's like the biggest thing with, particularly with the Filoween series of filament reviews. That's like the one big thing I tell pretty much every manufacturer. Hey, send me material, okay, that's cool, but please let me know what temperature should I print it on, at what surface should I print it on, should I use a cooling fan? You know, those sort of things. Many manufacturers give you like nozzle temperature and hot temperature maybe, and that's it. But that full set of parameters like Ultimaker has integrated, that's going to be one of the biggest steps in making 3D printing easier and more bulletproof. I would say by default the 3D printer has to, given how long prints can take. Okay, don't have context for that. Next up, what do I do with my failed prints? I think I answered that on some social media. I think it was Twitter recently. What do I do with my failed prints? So not that much, actually. Obviously, the three big materials are PLA, ABS, and PETG. So PLA I throw in the bio waste thing and hope it gets eaten up by some sort of bacteria they're using. And ABS and PETG, it just goes in the waste, in the trash, essentially, because no recycling plant is going to pick out a random bit of plastic when it doesn't even have the marking for what sort of plastic it is. And my hopes there are that at least like the waste trash, you know, everything but recycling, at least they sort through that with enough diligence to pick out the valuable plastic bits. And maybe they'll pick out the 3D printed stuff. I don't know. I'm hoping for it. If not, there's not that much that we can do, to be honest, when it comes to failed and outdated 3D prints when it comes to recycling them. Yeah. Okay, so that is that. Then Chase McNamara is asking, what do I think of E3D's new block socks? I do have 2 left of these socks. My Padawan has been using one for the last few weeks. It's going to take a bit more research, a bit more testing to really figure those out and see how much they can do when it comes to not needing as much part cooling. But I mean, the thing is, Prusa doesn't ship, or doesn't like them, at least, on his machines because he's saying that they fall off. It might be a trade-off. It might be, you know, a misuse thing where they actually fall off the print and get stuck, or fall off the heater block and get stuck to your print. Again, it's going to have to take some more research. I'm not 100% sold on the fairly loose clip-on design yet, but if they stay on reasonably well, they have the potential of just making the temperature-sensitive plastics like PLA that need a particle fan a bit nicer to print. That would be great. Yeah. So the last one actually here, guys. It's time you start posting your question in chat. That would be great. There's 19 of you. The last one here on the, oh, you can see I just managed to pause the video. Last one here, Tinkerman, struggling to print Tallman Alloy 910 or on his printer, and he had to use 290 degrees, and he's asking, hey, is there any way to determine whether or not the temperature in his hot-end or in a hot-end in general is accurate, and is there some way to calibrate it? So that's more or less a discussion at a very basic tech level, at a very basic engineering level. The thing is, the thermistors we're using today, they're great at like the temperatures we're using them. Maybe it's maybe a bit past, so like 200, 250 degrees, and that's like the reasonable range for thermistors. The problem is that they do get very inaccurate the hotter your thermistor, or the hotter the temperature they're supposed to measure gets. So while at around 20 degrees, around room temperature, they are very, very accurate. They can give you incredible precision and resolution. At the high temperatures, you know, one of them might have a, is this mirrored for you or is it not? I have no idea. Let's say it is mirrored. So let's say this is like the resistance, and we've got the y-axis with the temp, or the other way around, whatever. So one curve, temperature over resistance, might look straight. The other one might be a bit more curved. The other one might be a bit more curved the other way. So, you know, there is that range where you can use them and where they will generally give you accurate results, even if they have a bit of, you know, manufacturing tolerance. But at those higher temperatures, you're gonna get, you know, really big deviations from one to the next, and it's just not the best technology for measuring it anymore. And that's why you're seeing so few thermistors that are actually rated up to 300 or 350. Some manufacturers even claim degrees Celsius. So the better option for those would be PT100s to a certain extent, and thermocouples. And I guess the best way of calibrating a hot end is by using a thermocouple with just a multimeter. You can, many multimeters actually come with those tiny welded tip thermocouple leads. Just jam that into your heater block and measure the thing. It should give you a really good reading that at least you can use to offset your thermistor's reading. So that's like my recommendation. But the general problem you have when you don't have like an absolute measuring device like a thermocouple is, even if you have the way to offset in the firmware, you can definitely rewrite your thermistor tables in firmware. But even if you can compensate it, you don't have a real reference. You still don't know whether your thermistor is at 290 or 320 or even just 250. You have no idea of telling. So yeah, get it. Whoa. Image artifacts. Get a thermocouple, measure it, or if you want to just get a thermocouple upgrade kit, they're not that expensive, and they will just give you spot on. I'm seeing some image artifacts that is disconcerting. Thermocouple upgrades kits are not that expensive, and they will give you an accurate reading up to the very, very high temperatures. Some even go to like 1,100 degrees, which is crazy. Right. Let's have a look at chat. So I think I can actually zoom this one, and we can do the same chat embed effect here. So Boom, 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 boom. So never had a sock fall off. Socks don't fit 100%. So the thing with the E3D socks is the way E3D explains it, the ones I have, they don't fit super snugly, but as they heat up, the silicone expands and then they snap into place perfectly. I don't know. That's just what E3D is saying when you point out the non-perfect fit. Because when they're cold, they really don't fit well. Aluminum sheet folding offset from hot end is a better solution. Okay, so something like the Atom 3D does with the stainless steel shield. So Lee Robinson is asking, I've got some rigid ink ASA, what temps and speeds do I suggest? So actually, if you, I don't want to show you my browser history. If you actually go over to the wall of data for the Halloween series, why is my image stopped? This is not good. I have no idea if it's still broadcasting. I'm hoping it is, but come on, my Firefox is acting up. There you go. So it seems like it's calming itself. If you head over to the Halloween wall of data, you're gonna see the full print temp, bed temp, fan speed setting for all of the filaments I've tested in Halloween. So ASA is in there. Let's wait for this to load. I shouldn't have opened this up in Firefox. There we go. Okay, so now it's showing the screen. Hoping this is okay. Seems Firefox has calmed down. So in the wall of data, you're going to see the full. The full set of parameters that I used for testing the filament and that I got the best results with. Okay, let's just close out of that. That's not going to work. I'm going to have to use Chrome, but you get the idea. That document has all the info in there. So that's the temps and speeds. I'm using speeds are just the default settings from the MK2 slicers. So yeah, unless it's flexible filament. Video is smooth. Okay, but I saw no frame updates. So nozzle change. Wolfgang Shadow is asking. Nozzle change on the Mark II. I think that was on the comments of one of the posts on Patreon. Is it possible to swap the nozzle in the E3BB6 and the Mark II? It is possible. It's not the most elegant one because that carriage on the Mark II is just super tight, and even just removing the hot end in its entirety is a pain in the butt. And well, you can do it. You can sort of unscrew the heater block and then unscrew the nozzle. Works. It's not super elegant, but you can definitely do it. Also, Wolfgang Shadow is asking here, a shortage in the plug of the heated bed. Do I know the name of these plugs? Where can you buy them? So that depends on which plug you're talking about. So the I'm guessing that refers to the Mark II, but there are various types of plugs and things. I really don't know their name and which exact one it is. Right, the question from Go Eland 86 to follow up on the comments from earlier. What kind of feature would I like to see? Which do you think we will see, and when do you expect some of those features to make it into production? So I guess that refers to 3D printer features. 3D printer features that make them easier and more comfortable and more foolproof to use. So actually, if you have a look at the Markforged Mark II reviewed, they already have a few really nice features built in, like that that homing check every few layers, where the harden or the tool head just runs into the XY and stops, doesn't reset the position, but just checks whether the position it hits them at is still realistic. That's just one of the things, usually printers don't lose steps that often, but when they do, it's sort of frustrating to see that 18-hour print fail. So yeah, something like that. Then just the entire UI UX design. If your printer has an LCD, has some sort of display connected to it. What I'm starting to feel like is the Automaker 3 still has that tiny OLED. It has animations that no one needs, and it's slow to use. It doesn't feel efficient to use. And even something like the Mark II simple LCD that just gives you the handful of options you need, no fuss, it just feels so much better. Markforged also did a tremendous job on the interface they're providing on that, I think, 4.5 or 5-inch touchscreen. That felt extremely efficient and extremely polished. That sort of stuff just makes, if it's implemented well, it makes using your 3D printer easier, more comfortable, more efficient, and it just feels good. Having that interface that is polished just adds so much value. I feel so much conceived value, maybe not real value, but conceived one at least. Right. Yeah, and Lassie VVV. Let me see if I can find that original question. There we go. As Pazi L on Patreon. So yeah, just thinking when sometimes my printer gets very slow, lagging around holes, around fine details essentially. So that is a really simple answer, more or less. So Marlin on the Mega 2560, or buffer problems on Octoprint. So that is, let me just see if I can demonstrate it somehow. I can actually find a file that shows this. I guess this one should show it. 1 second while that opens up. I don't, why NetFab? I don't want to license you. I really don't. Okay, so let's pop it over here again. So that's a very simple cylinder standoff that I printed today. Needed 4 off, didn't feel like making it on the lathe, so printed it. Why not? If we head over to the repair mode, we can actually see the individual triangles. And the thing is, an STL can only approximate round surfaces. So each, the outer curved surface is split up into a huge number of individual triangles. That's not that much of an issue, but when you go to the inside holes, these are much finer segments, and each of these segments, is straight when the printer prints it, but it requires the same amount of processing power, the same amount of bandwidth when it comes to the communication between your host, your Raspberry Pi or 3D printer or whatever, and the firmware. So essentially, this small section has, these are down here, it's twice as much even, has maybe 30, 40 lines of G code that it produces, that the machine requires to print this. So just this short section is going to have 30 times or more processing power requirements than just a straight line of the same length. And that's the thing, Marlin, or the software serial port, well, it's not a software, it is an emulated serial port on some ports, on some boards, on others it's a serial to USB adapter, and that only has a limited bandwidth. So what you can do to avoid that is, first of all, if you're using CAD, just set the options, the export options, to less triangles, because this is a super small print, and it's 1,440 triangles, which is quite a lot. You'll be surprised by how many triangles certain models use up. Set the export resolution lower, or you can actually do that in Blender. If I can quickly pull that up. Let's see if I can do this quick enough. So, 1 second while I navigate to my glorious file structure. And I don't want to open, I want to import. There we go. So there is our cylinder in Blender. What you can actually do is import the STL, then go to the modifiers. You add the modifier decimate, and a few different options to choose which type of decimation you want to use. But you can drop that down usually pretty far and still get a model that is within the hold on, I haven't used Blender in a while. And you can usually get a model that is still within the limits of the accuracy of your 3D printer. So, for example, this is like 16% of the original triangles, more or less. You can go down even further and, well, make it abstract art. I guess this still has the same topology, but it doesn't have the same function. So, I mean, even something like this probably would have the same function as that original cylinder. And you hit apply, and now you have the new mesh they can export via file. Go on, file, export, STL, and it's all in the original model. This is going to create a much shorter G code, a much more efficient printing workflow, and it's just going to put much less strain on your machine and on the communication interfaces between a Raspberry Pi, another host, and the Marlin scheduler and planner on itself. Right. Any chance to have a session to discuss, print issues? You can sign up for the $60 a month Patreon level. My Hangout is jerking again. Yeah, stopping again. Right, you can sign up to the $60 a month Brain Picker pledge level on Patreon and get one-on-one Hangouts on Hangouts, I guess. The thing is, I don't have the time, the temporary resources in that case to do one-on-one consulting sort of Q&A sessions. So hire me for consulting if you want to go for the $60 Patreon pledge, or join on one of the Q&A Hangouts, 3D Senpai, if you want to do that. I don't know when I'm going to have the next one of those, but the other option, of course, is communities. The 3D printing community on Google+, I don't know, 300,000 people or so. 3D printing communities on Facebook. They can provide a huge amount of help if you need assistance with your with the 3D printer results. Right. So to finish it up, LaCVV, Mega Raspberry update do not help problem with serial port maximum speed. Exactly. That is the serial port maximum speed and the processing power of your 8-bit control board. Those two, one of the times it'll be one, then it'll be the other, but it is something that is just a limitation of the hardware in that case. So yeah, make your model simpler, and that should solve that. All right, 40 minutes done. I guess that I think we got through all the questions. I think that concludes it for today. As always, thank you for being here. The recording of this Hangout will go up on will be available in the same link. I'll repost that. Again, thank you for supporting me on Patreon. That makes a huge difference to me, as I do like to point out. And I'll see you in the next videos, next live streams, and next month's Hangout. All right? Bye-bye.